Welcome to The Explainer. Today, we're taking a look at how some really cutting-edge technologies, like AI and passkeys, are being targeted by attackers using some surprisingly old-school tricks. It turns out the future of cyber threats might look a whole lot like the past.
Okay, let's just dive right in with a question that honestly sounds like it's straight out of a sci-fi movie, but it's happening right now. What happens when the bad code isn't just following orders, but can actually think for itself?
And yeah, that question leads us directly to our first big threat. Malware that's not just following some pre-written script. We're talking about malware that uses powerful AI to write its own malicious code, on the fly, right on the victim's machine. So here's the crucial thing you gotta understand. We're not just talking about AI helping criminals write malware in some secret lab somewhere. No. We're talking about malware that has an entire AI engine baked right into it. It literally improvises its attack in real time, which makes it incredibly unpredictable and a total nightmare to detect.
Researchers have actually given this new threat a name. They're calling it malterminal. And what makes it so alarming is how it takes the power of a trusted mainstream AI like GPT-4 and turns it to the dark side. So once it's on a system, malterminal is just brutally efficient. It basically gives the attacker a menu. Do you want to encrypt the victim's files for ransom, or do you want to create a secret backdoor for total control? And then, get this, it just asks the AI to write the code to do it, right then and there. But, AI isn't just creating brand new threats, it's also being turned against the very tools that we're all starting to rely on. And this is where the threat becomes, I think, even more insidious, because it turns our own AI assistants against us. Imagine this for a second. You ask your AI assistant, like ChatGPT, to summarize your emails to save you some time. But while it's helping you out, it's also secretly copying your most sensitive data and shipping it straight to an attacker. So how is that even possible? Well, it's through this really clever technique called indirect prompt injection. The best way to think about it is like leaving a secret message for the AI that's written in invisible ink. A human would never see it, but the AI reads it and just follows its hidden orders. And what's really wild about this specific attack, which researchers have called shadow leak, is how it works. It hides these malicious instructions in plain sight using these super old school tricks like white text on a white background or a font size that's just impossibly small. So you see a totally normal email, but the AI sees a secret set of commands. And this is basically a simplified version of that hidden prompt. The attacker is literally speaking the AI's language, telling it to first mark the email as safe for the human, and then, in the same breath, turning it into an accomplice to go steal data from the rest of the inbox. It's crazy. And this just illustrates the entire process perfectly. It's what we call a zero-click flaw. The victim doesn't have to click on a malicious link, they don't have to download some weird attachment. All they have to do is use their AI assistant as intended, and their data can get stolen right out from under their nose. Okay, so we've seen AI as the attacker and as the unwilling accomplice. But now for a really fascinating twist. What happens when our most advanced security solution gets defeated by one of the oldest, simplest tricks in the book? Let's talk about passkeys. These things are supposed to be the answer to all our password problems. They're designed to be totally revolutionary because you can't guess them, you can't steal them, you can't phish them like passwords. They're really our best hope for a truly secure, passwordless future. This is the exact vulnerability a security researcher demonstrated at this year's DEF CON, which is one of the world's biggest hacker conferences. He basically showed that even the unphishable can be phished, if you're clever enough. The attack uses this classic technique called clickjacking. Here's how it works. You think you're clicking close on some annoying pop-up ad, but you're actually clicking an invisible login with passkey button that an attacker has hidden right underneath it. So how does an attack like this actually get around a system that's specifically designed to be unphishable? Well, the vulnerability isn't in the passkey itself. It's in hijacking the login process. This process effectively hijacks the entire authentication ceremony. Now, to be super clear, the attack doesn't steal your passkey. It can't. But what it steals is basically a one-time golden ticket that's generated by your passkey. And that ticket lets the attacker log in as you just that one time. And the wild thing is, this whole attack is only possible because of a really fundamental, almost basic security oversight. The website fails to bind the login attempt to your specific individual session.
And without this binding, that stolen golden ticket can be used by anyone from anywhere in the world. It's a really well-known security best practice that, when it's ignored, leaves the digital door wide open, even for a system as strong as Passkeys. And this really brings us to the core lesson of today's explainer. These futuristic attacks, they aren't just about flaws in new tech. They're about how we implement it and the shared responsibility that all of us have. Honestly, pointing fingers here is pretty useless because security is a layered process. Of course, website operators have the biggest role. They have to implement session binding, but password manager vendors can add better warnings. And we, as users, we have a part to play by configuring our tools to be more secure, like, say, requiring a PIN for every single login.
So, what you should really take away from all this is that whether the threat is self-writing malware or a hijacked passkey, the defense so often just comes down to getting the fundamentals right. Innovation is awesome, but it can't come at the expense of basic security principles.
As we all race to build the future, this final thought is really worth considering. Are we just destined to repeat the same basic errors with each new wave of technology? Something to think about. Thanks for tuning in to this explainer.